Welcome back. Let's implement one last feature in our hash table over here. I want to create something called keys. And keys allows us to iterate or loop through all the keys of our hash table. In this case, grapes and apples. And let's add a few more just for fun so we see what's going on. We'll add oranges, and we don't like them too much, so we're only going to add 2 of them. Now, if we run keys, ideally, it's going to iterate and spit out grapes, apples, and oranges for us to see what we need to go shopping for. How would we go about building this? Well, because we're going to do some sort of looping, I'm going to start off by creating a constant. Let's call it keys array. And this is going to be an empty array. Within here, we're going to loop. So for let I equals 0. And as long as I is going to be less than this.data.length, we're going to increment I. In here, we're saying we want to loop through all 50 item spaces. All the shelves, one by one, we're going to loop through them. Yep, that's a lot of iterations. And if in the shelf there is some sort of data, if it's not undefined, completely empty, and there is something valuable for us that we want to look, because remember, we allocate 50 spaces on the shelf, but we've only placed 3 items or 3 data points on that. So if there is something in that memory space, in that case, we can just say keysArray.push this.data, and we grab the index, so the first array or the array that we're at right here, and then we want to grab apples, right? Well, if I do 0 here and now hit run, well, we have to return something. Let's return here the keys array at the end of all of this. So after all the loops, we're going to simply say return keys array. If I run this, I get grapes, apples, and oranges. That's fantastic, but I just wanted grapes, apples, and oranges. To see what's going on here, let's console.log this.data I, which is what we're doing here, what we're pushing. And if I run this, we see that we get arrays within the array. Because remember, we have one massive array, and each time we create a new shelf space, we have to have a new array that we create and we push into that. So a little bit of a gotcha here. We have to say 0, which removes the outer array, and now another 0 to grab the first index of this array. Just like that. So if we add another 0 in there to access the first index of the array, we click run, look at that. We get grapes, apples, and oranges. Well done. We've just implemented a hash table. And you may have noticed something, a downside of hash tables. We had to loop here, right? We had a for loop, looping through the entire memory space in order to find our keys. That was so much easier with arrays. With arrays, we would have had just 3 items and we would have looped over 3 times. Instead, here, we looped over 50 times. Imagine if we had 500. That's even more. How exciting is this? We're starting to learn how things work underneath the hood so that now we have an idea of, maybe if we're using this type of method, objects might not be the best idea. And that's one drawback of objects or hash tables. In JavaScript, we can use something like for in loops to loop over items in an object, which again is very, very slow. And as you might realize, there's no guaranteed order. Every time we're just adding something to our address, but when we grab items from the address, we just go from 0 to 50, even though the items are just randomly placed in different shelves. But I hope now you actually get to see how it works. We're putting items randomly in a shelf, but when we retrieve them, they're all unordered. And that's why coding things out, even though you most likely won't get this asked in an interview, knowing how things work allows you to talk about them intelligently. And I hope this exercise has done that for you. I'll leave this for you to play around with and perhaps add different methods like values that grabs the values instead of the keys. But for now, let's finalize our talk of hash tables by comparing them to arrays.